edition of our circle theorem lessons. So in this video, we are going to consider theorem 5. You look at theorem 5 in this video. So this theorem 5 is called the alternate segment theorem. So the name of this theorem is called the alternate segment theorem. So what does this theorem say? What does this theorem say? So this theorem says that the angle between a chord, you see a chord, and a tangent. We learned these key terms during the part of what, when we were looking at lesson on the part of circles. That's why we were saying that it was very important for you to know these terms or this. Otherwise, you know, you to understand. So we say that the angle between a chord and a tangent, so if you have a chord and a tangent, is equal to the angle in the triangle formed by the chord in the opposite or alternate segment. The angle between a chord and a tangent is equal to the angle in the triangle formed by the chord in the opposite or alternate segment. So opposite is the same as what? Alternate. Okay, fine. So let's look here. So hope you know what a tangent is. A tangent is a line that touches a circle at one point. So this is a tangent. This line T. That's why I've written T here. So this is what a tangent. And then this is what a chord. So a chord is just a line that joins what 2 points on the circumference. So the diameter is a special chord. I hope you know that diameter is a chord. Yes, diameter is a special chord. Just passes through the center, divides the circle into 2 equal parts. So this line is a chord. This line is also a chord, and then this line is also a chord. So we are saying that the angle between a tangent, this theorem says that the angle between a tangent, this is a tangent, and a chord, so this angle y, this angle is equal to what? It's equal to the angle in the triangle formed by the chord. So this chord, this tangent, this is the angle between the tangent and this chord. So this chord is forming a triangle. Look at this. This is a triangle formed by the chord. This chord is forming this triangle. So this angle, so we are saying that the angle between this tangent and this chord is equal to what? The angle in the triangle formed by the chord in the opposite or alternate segment. So have you seen? So if you have this side, this side is a segment, and then from the whole of this side to the other part of the circle is what? Is another segment. So this chord forms this triangle, and this triangle formed by the chord, which of the angles is opposite to this segment? It is this angle. Have you seen? So we are saying that the angle between this tangent and this chord is always equal to the angle in the triangle formed by this chord in the opposite one or alternate segment. So that's why this angle is y, then this angle is also what? Y. And then in the same way, this tangent is also making an angle of x with this chord. So this one is what? This side, this is a segment. This side is a segment, and this from this side to this side is a major segment. So this chord is forming this triangle. So which angles in this triangle is opposite to this side of the segment? To this segment. It is this angle. Have you seen? This angle in this triangle formed by this chord is opposite to this segment. So this angle is what equal to what? This angle. So that is the alternate segment theorem. Say that the angle between a tangent and a chord is always equal to what? It's equal to the angle in the triangle formed by the chord in the opposite segment, alternate segment. Okay, fine. Let's look at this one. So for this one, I've shaded this. Okay, so you see that this line is what? Is a tangent, and this is the angle, and this line is what? Is a chord. This line is another chord. This line is another chord. So this tangent is what? It's making this angle with this what? With this chord. Have you seen? And then you see that because this is a chord. This line is a chord, and this section, this shaded portion is shaded in yellow. Is what? Shaded in light yellow or light yellow or like orange. Yes, this shaded portion. This is what I mean. Have you seen? This side, this is a segment, and the whole of the green, the shaded portion in green is what? It's another segment, a major segment, and this one is a minor segment. So the tangent, this tangent meets this chord here and forms this angle here. It forms this angle with the chord, with this chord. And then we are saying that this angle, the angle formed by this tangent and this chord is equal to what? The angle formed by the angle in the triangle. Okay, let me take it once again. The angle between this tangent and this chord is equal to what? The angle in the triangle. This is the triangle formed by what? The chord. The triangle formed by the angle in the triangle formed by the chord in the opposite what? Opposite or alternate segment. So this chord forms this triangle. So which of the angles in the triangle formed by this chord is opposite to this segment? It is this angle. So this angle is equal to what? This angle according to the alternate segment theorem. So if you stand here, it means that this side, you see, this chord, this tangent is also making an angle of what? This angle with this one, with this chord, and then this chord forms this triangle. So the angle that is opposite to this segment is what? Is this triangle. So it means that this angle is equal to what? This angle according to what? The alternate segment theorem. Okay, let us look at. Yes, so we are looking at this side of this side. So we are looking at this side in this diagram. So this one is what? Minor segment. So this one is what? Okay, this is the minor segment. This is the major hot segment. Okay, from the whole of this from here to here is what the major segment. From this, the one in green is the minor segment. So have you seen? So this is the tangent, and then you meet this chord. This is a chord. This is a chord. This is a chord. So we are looking at this chord. This chord that meets this tangent at this point. So you are saying that the angle between this chord and what? And this tangent, this angle marked with red, is equal to what? It's equal to the angle in the triangle. In the triangle formed by the chord. This chord is forming this triangle. So what angle? Angle in the triangle formed by the chord opposite to this one, to the segment. So this is the triangle formed by this chord. And in this triangle formed by this chord, which of the angles is opposite to this segment? It's only this angle. So we are saying that this angle is equal to this angle. So let's look at this one. See, look at this. So this one is a tangent. Is it not? Isn't it? This is a tangent, and then this is a chord. So this tangent is meeting this chord and then forming this angle. And then by this one, look at this chord. This chord is also forming this angle. Look at where the angle is formed. Is it formed? Does this angle form this thing? Does it touch the circumference? No, it does not touch the circumference. This side doesn't touch the circumference. So it means this is not this is not the alternate segment theorem. The alternate segment theorem doesn't hold here. So we are saying that you have to note that what? All the three vertices of the triangle formed by the chord must touch what? Must touch the circumference. So if you want this to be the alternate segment theorem, then this side must extend. They have to come here and come and meet on the circumference. But since they are not meeting on the circumference, they are meeting somewhere here. This one is not part of the alternate segment theorem. Have you seen? So the alternate segment theorem, in the alternate segment theorem, or the triangle that will be formed by the chord, all the three vertices of the triangle must touch the circumference. All the three vertices here, all the three vertices are touching the circumference. Become the other three vertices form the chord. The triangle is formed by this chord, but all the three vertices are also touching the circumference. This triangle formed by this chord, all the three vertices are touching the circumference. And this side, this chord is also forming this triangle with all the three vertices touching the circumference. So that is the condition. If all the three vertices don't touch the circumference, then you cannot, the alternate segment will not go. So that is this. We are saying that the alternate segment theorem says that the angle between a chord and a tangent is always equal to what? Equal to the triangle formed by what? Formed by the chord in the opposite what? Sorry, the angle between what? A tangent and a chord is always equal to the angle in the triangle formed by what? Formed by the chord in the opposite or alternate segment. Thank you for watching. See you in the next video. The next video we look at an example. Thank you for watching. See you. Okay, so students, you are welcome back. Let us look at an example on theorem 5, on the alternate segment theorem. Alternate segment theorem. So in this example, we are to find the value of say find s, and find x angle BAD and what angle ABC. We are supposed to find x and angle what. So this is x and angle BAD. What is that? Where is angle BAD? Angle BAD. This angle. I'm supposed to find this angle and what? Angle ABC. Where is angle ABC? Angle A, B. This angle ABC. Okay, fine. So first of all, we know that this angle is given to be what? Is given to be 19 degrees, and this angle is also what? 15 degrees. Sorry, 57 degrees. Sorry, 57. This angle is 57 degrees, and this is what? 19 degrees. And then we know that this is a tangent. The tangent meeting the circle at this point. And then this tangent is what? This tangent meets this chord at this point. And this angle is the angle between what? This tangent and this chord. And this same chord is forming this triangle on the circumference. So according to the alternate segment theorem, the angle between this tangent and this chord is equal to what? The angle in the triangle formed by this chord in the opposite segment. So this angle is opposite to this segment. Fine. So this angle, it means that this angle what will be 19 degrees. So you see that from the what? From the alternate from the alternate segment theorem. Angle what? Angle B is angle BAD. Angle BAD. This angle BAD. This angle is equal to what? Is equal to 19 degrees. Angle BAD. Angle BAD is equal to what? 19 degrees. Fine. So this angle is what? Is 19 degrees. Fine. So we have to find what? We have to find x. So this is the same. This tangent. This is the line. This is the same. The tangent. This tangent is meeting this chord. So we know that this is not the diameter. We see this looks like the diameter. This question we are not told that this is the diameter. The center is not indicated here on this line. So if you are not told that a line is a diameter, don't assume. You look at that in the subsequent lessons. So you have this angle and this angle. So this is the alternate segment theorem. So this one is what? Is a segment, and then this one is also a segment. So the angle between this tangent and this chord is equal to what? The triangle is equal to the angle between this chord and this tangent is equal to the angle in the triangle formed by this chord. So this chord is forming what? This triangle. The angle in the triangle formed by the chord in the opposite segment. So this angle is opposite to this segment. So it means that this angle S is equal to what? This angle. But how can we find this? So if you know this, you know S, then we can also what? You know this definitely. So we know this side is 19 and this side is, don't know this, and this side is 57. So this is a triangle. Using the triangle, so we say that from what? From triangle what? A, B, C. We can find the angles in the triangle are toward 180. Angle B, C. What does it imply? It implies that angle what? Angle ABC, angle A, B, C plus what? Plus 19 plus 57 is equal to what? 180 degrees. So angle what? A, B, C plus 19 plus 57 is what? 76 is equal to what? 180. So angle what? A, B, C is equal to what? 180 minus what? 76, which is equal to what? Which is equal to 104 degrees. 104 degrees. So this angle is equal to what? This is 104 degrees. 104 degrees. So if this is 104 degrees, then from the alternate segment theorem, S is equal to what? This angle. So you say that S from what? From the alternate, or sorry, from the alternate segment theorem. From the alternate segment theorem, S is equal to what? S is equal to 104 degrees. So that is it. So it means that S is equal to 104. Angle BAD is equal to what? 19 degrees, and angle ABC is equal to what? 104 degrees. So that is it. So thank you for watching. See you in the next video. So just don't forget to subscribe to the channel. Get understanding. Don't memorize. Thank you. See you in the next video.